Hi everyone. Pre-calculus 1-7, inverse relations and functions. So we will deal with this horizontal line test. So number of you are familiar with the vertical line test. Vertical line test is used to tell whether the function or graph is a function or not. Whether the graph is a function or not. What is a horizontal line test then? Whether its inverse is a function or not. So I'm not talking about this graph itself. Whatever its inverse is its inverse a function, yes or no? So you do a horizontal line test. So any horizontal line cannot pass the graph more than once. It shouldn't pass, or it should pass only once. Then it passes horizontal line test. What does that tell us? Its inverse is a function. And we denote inverse as like this. It looks like a -1 power. It's not a power, it's just inverse function notation. Okay, graph the function following using a graphing calculator and apply horizontal line test to determine whether its inverse function exists. So as you can see, if you graph using graphing calculator, it's a parabola. You put horizontal line here, it passes once, twice. It fails horizontal line test. Inverse function? No. There is no inverse function. Same question, graph this using graphing calculator, horizontal line test. Anywhere you put horizontal line, it will only pass once. Passes. What does that mean? Its inverse is a function, or inverse function exists. Graph this using calculator, do horizontal line test. So if you graph it, it would look something like this. Horizontal line test, it will pass. It passes only once everywhere, except here that it doesn't pass at all. So it does pass horizontal line test, which means inverse exists, or its inverse is yes function. Finding an inverse function. So first, check it by horizontal line test whether its inverse exists. If inverse exists, here are steps. Replace f of x with y. That's step number 1. Step number 2, interchange x and y. Swap x and y. Solve for y. Third steps. Replace y with function notation inverse of f of inverse function. Then state any restriction domain of f of inverse. Then show that domain of f is equal to the range of f inverse. Then range of f is equal to the domain of f inverse. So this part, what it means by that is function f and inverse function. Whatever domain is, range is, that becomes range. Range of original function becomes domain. Input, output gets swapped. That's what's going on with inverse function. So original function domain becomes range of inverse function. Original function range becomes domain in inverse function. Determine whether f has inverse function for this function. If it does, find inverse function. State any restriction on its domain. Okay, if you graph this using calculator, it looks like this. Horizontal line test, yes, it passes. So inverse function exists. Then find inverse function. So let me just show you. Find inverse. First, function notation f of x, replace with y. Rewrite using y. Second, interchange x and y. Swap x and y. So wherever y, I wrote x. Wherever x appear, I wrote y. Then what? Solve for y. Solve for y. Okay. Do you see y on numerator, y on denominator? You don't want that. You don't want y on denominator. So you want every y on the numerator. So what do? You multiply by denominator both sides. X times 2y minus 1, y over 2y minus 1, you multiply by 2y minus 1, right hand side as well. 2y minus 1. This thing cancels out. So you distribute x here, it should be 2xy minus x equal to y. Then every y is on the numerator. What are we doing here? Solve for y. Yes, y. No y. Yes, y. So when you solve for y, you want all terms with y one side, terms without y on the other side. Yes, y. No. Yes, y. So why don't I move yes, y to the right? So I want this term to be on the right. Minus 2xy, minus 2xy. So I got minus x equal to y minus 2xy. So I got no y, yes, y, yes, y. Then what? Solving for y, you gotta factor out y. So you gotta factor out y from here. So some of you, if you're not familiar with what do you mean factoring y out. So y is here. Factoring y means just divide by y. It becomes 1. So minus 2xy. So you might say, what do you mean factoring y out? You're dividing by y. So what's left over? Minus 2x. That's what I mean by factor y out. So when you distribute y, you can get this expression. Solving for y, you want y to be by itself. So you want this whole parenthesis disappear from right hand side. How? Divide by parenthesis, both sides. So you got y equal to minus x over 1 minus 2x. Okay? I don't like to write like this. I want to write descending order of x, power of x. So I don't like to write constant first. So I'm going to swap this. Minus x over minus 2x plus 1. That's same as this. Do you see you have a minus x and minus, the leading coefficient is all minus here. Nothing wrong with this. Did they do anything? Yeah. Nothing wrong with this, but just I don't like leading coefficient as a minus, leading coefficient as a minus. So what I will do here, I will multiply by minus 1 over minus 1. So I basically, you cannot change the expression. So I'm going to just multiply by 1. But 1 such that 1 is minus 1 over minus 1, which is 1. So I'm not changing anything. But when you multiply by minus 1 here, you're changing that as x. You're multiplying by minus 1 here, multiplying by minus 1 here, you get 2x minus 1. So for this, since you have a leading coefficient as a minus minus, I don't like that. So if you multiply by minus 1 numerator denominator, it becomes a lot nicer. Okay, so that's good practice for you to do. So you solve for y, then what? Replace y with a function notation. We found the inverse function, f of inverse function equal to x over 2x minus 1. That is your answer. And it's asking find the domain. So you should be familiar with the finding domain of rational function by now. So denominator cannot equal to 0. Plus 1 both sides divided by 2. X cannot equal to 1 over 2 is your domain. And for Alex, they want interval notation. So 1/2 here cannot be, so make that empty dot. And you have to express interval here, interval here. So that's what? Minus infinity to 1/2 union with 1/2 through forever, 1/2 comma infinity. That will be your domain. And that's your inverse function. Yep. Okay, determine whether f has an inverse function for this. If it does, find the inverse function, state any restriction on its domain. So if you graph this, it looks like something like this. Horizontal line test, it will pass. So inverse function exists. Find the inverse function. So let me do that again. Replace f of x with y. Swap x and y, interchange x and y. X equal to 2 square root of y minus 1. Then what? Solve for y. From here, you're solving for y. Get rid of 2. Divide by 2 both sides. X over 2 equal to square root of y minus 1. Time to get rid of square root. What do? Square both sides. You got a square here, square here. So that's x squared over 4 equal to square root disappears. Solve for y. Plus 1 both sides. X squared over 4 plus 1 equal to y. So you got y equal to x squared over 4 plus 1. Y you replace with the function notation. Inverse of f of x. X squared 4 over 1. Okay. If you stop here, I'm going to lose you. You did all the work beautifully. You have to be a little careful when you start with the square root in the beginning. Why? So if you look at this original graph, you got range as, range means how low graph can go. How low graph can go is 1 here. 1, and you can go forever to the upward. So range, given this graph of original function, range will be 0 and infinity, and 0 is actually inclusive. That's your range. We might say, why does it matter? The range of original function becomes domain. So domain is 0 through infinity. You might say, okay, how does it affect our answer? This is actually parabola. So if you graph that, it looked like parabola like right here. But you just leave that as it is, then you are saying this is my entire parabola is my inverse function, which is not correct. That not entire function is inverse function, only this portion. Domain is 0 or higher for x value. So out of entire graph of something like this, you're dumping this part. It has to be, the domain has to be 0 or higher. So you're only taking this portion. Okay? So when your original equation square root, you have to consider range, and that range becomes domain. So your answer should be this. This with a domain restriction. Sometimes you say that, or you can say x is greater than or equal to 0 with a comma. You can say that, you can say that, okay? So that's the graph, that's the um, equation of the inverse function, and domain is there. Okay, pause this video, please. You should try to find its inverse function. Okay, so let me just do this. F of x equal to x plus 2, x minus 1. So if you graph this using graphing calculator, do horizontal line test, you will pass. How do you find the inverse? Replace with y. Swap the x and y. Solve for y. So you will have to x times y minus 1 equal to y plus 2. You're going to multiply by y minus 1. This thing disappears. Xy minus x. You're distributing x. Okay. Solve for y. I want the all y. Whoa. Yes, y. No y. Yes, y. No y. I want all y to be on the left. So I'm going to minus y minus y. Xy minus y minus x equal to 2. I want no x, no y to be on the right. So I want this plus x both sides. Xy minus y, x plus 2. So I moved all terms with a y on the left, no y on the right. Factor out y here. Factor out y. So again, be careful. Factor out y means dividing by y. So you got x left here. Minus y here, factor out y means divide by y. So you got minus 1. Solving for y, you want this parenthesis disappear from the left-hand side. What do? Divide by parenthesis, divide by parenthesis. So this cancels out, so y equal to x plus 2 all over x minus 1. We are almost there. Just to replace y with the function notation, inverse f of x equal to x plus 2 all over x minus 1. That is an inverse function. And if you ask about the domain, denominator cannot equal to 0. Denominator cannot equal to 0. So x minus 1 cannot equal to 0. Okay? Okay, so let's start right here.